Good morning, everyone. My name is Laura, as you have just learned. I do live in Berlin. However, it is not far, but it took me a long time to get here because I was flying on Lufthansa, which meant yesterday I was not flying because they were on strike. But hopefully everything is okay and I can successfully leave. I do work at CodeShip. I'm an engineer, and if you're not familiar with CodeShip, it's a company that does continuous integration, continuous deployment. We have an office in Vienna, we have an office in Boston, and then I am the sole longshore woman in Berlin. If you want to talk to me about CodeShip, you can come talk to me afterward. I'm not really going to talk about CodeShip much during this talk, but I do love to talk about it. So just find me after, and I'm happy to answer any question. Today, I'm going to talk just mostly about building web applications with Docker. So there's kind of a lot of stuff that goes into it. We'll split it up into three main things. So first, we'll talk about actually what containers are. Why are they different from virtual machines? Should we even be comparing them to virtual machines to begin with? We'll talk about the Docker ecosystem. If you're using containerization in any way, shape, or form, chances are that you've probably used it in the context of Docker. So we'll talk a little bit about the tools that Docker offers. And then finally, we'll talk about working with Docker on a web project. And throughout the talk, I want to emphasize that what I'll be covering is not a specific solution for any one particular problem. Instead, I'm going to introduce you patterns that will be helpful with whatever type of project you're working on. So I might not cover specifically the language that you work in or the framework. I might even show you things that are kind of beginner for Docker that maybe as you get more advanced are probably not good patterns to use, or not a good solution, but rather the pattern is what you should be paying attention to. So with that, we'll get into what is containerization, why are we all kind of going crazy about it in the last couple years. And the problem, or not the problem, but it's likely that you probably have learned about containers in the context of the big blue whale known as Docker. I want to be really, really clear. This has been sort of problematic as people are becoming more familiar with containers in context of Docker, that it's easy to make the assumption that Docker equals containers. In fact, Docker is not a container. Docker manages containers. Docker is just a tool or a group of tool sets. So if you say, I'm going to run something in a Docker, that language isn't correct. You're running it in a container. The containerized processes are kind of wrapped in this Docker tool. There are other things that you can run containers with that are not Docker. It's just that Docker makes it really easy, which is why people use it. So as I said, Docker manages containers. So it does a couple things. Docker will build the image that you will run inside of a container. You can, in fact, manage entire applications with docker-compose, which is a templating tool that Docker makes. You can even provision a fleet of machines, of virtual machines, with Docker machine. There's other things like Docker Swarm. There's networking volumes. There's a whole bunch of tools to support containerization that Docker has made and has available open source for you. But the container is really the unit that we'll be working with. That's the kind of ground floor of everything that we'll be talking about. And a container, in very simple language, if you're not familiar with a concept abstractly what a container is, you can think of it as a sort of virtualization layer with some fundamental differences. It's very frequent that people will compare a container to a virtual machine. And I think that's an okay explanation if you're not quite familiar with what containerization is. But as you get a little bit further along, or you want to start working with containers, thinking about a container as a virtual machine doesn't really get you very far because the comparison isn't great. A container is just a process that kind of wraps other processes. So a container, the very simplest definition of one is that they are just a self-contained execution environment. Everything that is running in a container is just being executed in isolation from other things that are being executed. And the reason this isolation is so important is because containers do share the kernel of a host system. So you could have a virtual machine with 1,000 containers on it. I'm not saying you should, but you could do that. So having the containers to be isolated, the processes are isolated from other containerized processes is very important. And because they're kind of small and they're not as bulky as a virtual machine, they have very fast boot times and low overhead. I'm going to kind of abstractly show you what an application, specifically a web application, would look like if you were building it kind of in the traditional virtual machine way, where you have maybe one service per virtual machine and all your virtual machines are talking to each other. versus having it in containers. Maybe you have all of the containers on one virtual machine. So this example is an application that's running on 3 separate virtual machines. These lighter blue blocks at the top, if you think of each column as a separate virtual machine, that's kind of what this design is meant to show. So starting at the very bottom, you have infrastructure in a host OS somewhere, whether it's in your parents' basement or on Amazon or somewhere else. There's a hypervisor that's in control of the virtual machines that are being run. And then on each virtual machine, we have service 0, service 1, service 2. Each of those is kind of its own entity. We have libraries and binaries and a guest OS, and they're sort of in their own little happy place. This is pretty common if you're, for example, running a Rails application, then you have Postgres running in some other virtual machine somewhere else, accessible via network. The containerized way of doing this exact same workload doesn't look actually too different, but there are some pretty important differences. So first is that we can get rid of some stuff. We'll get rid of the guest OS and get rid of the hypervisor, and instead introduce something that's called a container runtime engine. In the case of us working with Docker, this is Docker. So this is the point that Docker or whatever runtime engine that you're using becomes important. It's the thing that's sort of separating the workload that you specify, whether it's an application or database, et cetera, with the actual infrastructure that you're running it on. This all can seem very complex. Like, why would I bother? My virtual machine setup is already working. But if you can start using containers and transition to containerization, using containers as kind of the unit that's shippable will greatly reduce the amount of time and space you need to run your application. So like I said, containers and virtual machines can be run together. They're not mutually exclusive. The difference is that instead of having one service on a virtual machine, when you introduce containerization, you can have multiple containers on one virtual machine. So you have a better opportunity to have high availability applications when you're using something like containerization. It's about service density and getting the most out of your infrastructure, and containers are an easy way to do that. The other thing is that they're very fast. So if I could summarize why you should be interested in containerization, it would be that you can just spend less time provisioning, rebooting, fighting with dependencies, and more time building what you want. The dependency thing will become important, and we'll see a couple examples that I'll do some live demos in a little bit. Containers are really helpful in development workflow, and personally, I use containers only. I don't have stuff installed on this machine. I have Docker machines, and I have everything, all of my dependencies installed somewhere else. So I'm always running something wrapped in a container. And that makes it so that if I make a mistake, which I do all the time, if something goes terribly wrong, all I have to do is reboot the container or restart the container. I don't have to reboot a virtual machine or reboot my own laptop. It saves me a lot of time and kind of insulates me from a lot of the mistakes that I make throughout my day developing. So with that knowledge of what containers are and why maybe we should be interested in using them, I want to talk to you about a little bit about the Docker ecosystem. Docker has grown from this very small engine project to now a crazy, huge, kind of all-encompassing workflow system. It was a very small project that started in Paris, and now it's, there's the 3rd, 4th DockerCon happening in Barcelona next week. There's tons and tons of people following the project, tons of contributors, lots of enterprise companies are using it. So the Docker ecosystem has had to adapt for that amount of load kind of on their tools. And how they've done that is to separate themselves kind of into 3 main groups. So they build, ship, and run. That's what Docker will say that they can do for you. They will build, ship, and run your applications. For us now, we'll talk about mostly building, because we're developers, and that's the part that's most important to us in our daily lives. And in order to build something with Docker, in order to run a container, you have to first start with a Docker image. I get this question a lot, and this mistake is made a lot. Are images containers? And the answer is no. You don't pull down a container. You pull down an image, and then you run it in a container. So if you can think kind of abstractly as the image that you have that you're going to run is sort of like the class, and you can think of a container as sort of an instantiation of the class. So the image is the thing that you're going to build. The image will be the thing that you distribute. The container is sort of the process of when you run the image. And if you get started with Docker and you're kind of just looking to, poke around, you'll probably be, it won't take you too long to get to this place, which is called the Docker Hub. So this is a public repository. It's the way that images are stored and shared and the way that code is stored and shared on GitHub are pretty similar. So it's the Docker Hub versus GitHub. You can kind of think about them working in the same way. The Docker Hub is a public repository that Docker hosts. I think at last count, there's around 15,000 images. There's probably more by now. And it also includes additional features like webhooks, build triggers, authentication, etc. You also can have private repositories similar to how you can on GitHub. And to interact with this registry, this repository, the Docker Hub, you are either going to use a web GUI, which is what I showed you on the earlier slide, or you will just interact with it, the repository and registry, through a CLI. Similar to how you will git, push, pull, etc., you can Docker, push, pull, do all sorts of things like that. They have incredible, excellent documentation that's very thorough. They just redesigned them, so it might be a little glitchy. You might not find information where you're expecting to, but they're working on it. The content is all there. They just did some reorganization, but I would highly recommend that you check them out. It's at docs.docker.com, and I will be bringing up that URL a lot because Docker is very complex, and you should read the docs. On this public registry, you have a couple different types of images, and if you're just getting started, it's easy to kind of get lost into what it is exactly that you're looking for. So I kind of classify images in 3 different buckets. The first is a service image. So a service image is a self-contained piece of software, basically. Postgres, Redis, MySQL. You can pull down this image and run it in a container and have the service available for you to consume immediately without having to do anything extra to it. So if you're interested in containerizing a part of your application, say you want your database to run in a container, you can just pull it down. Of course, you might have to do some configuration on other parts of your project, but this is kind of that service type of image where you pull down a specific thing, it's run, and it's consumable for you immediately. The second type is the exact opposite of that, which are what I kind of call project base images. So these images are intended to serve as a base for your project, but they don't actually provide a service. Any language image is like this. So Ruby, Python, the Golang images, you can pull it down, and if you run it, you will literally have nothing. You have to either add your code, do some customization in order for it to make, to be purposeful, in order for it to actually deliver something. These are great as developers when you are using them in your development workflow. You'll pull down a project base image, layer your project on top of it, and then those 2 things together will make your service available to be run in a container. I'll do some live demos in just a little bit, and that's exactly what I'll do. And then the third type of image is not really, it's not very similar to service or project base, but it is a special classification on the Docker Hub itself, which are official images. So these can be either project images or service images, but they are maintained by the organization or the open source community that maintains the code. So for example, the Rails image is maintained by the Rails community. If you pull down the official Rails image, you know that you're getting the thing that the Rails community has intended it to be. Postgres, MySQL, a lot of these kind of service images have official tags so that they're trusted. You know where they're coming from. But of course, you don't always want to just be pulling stuff down from other people's repositories through the registry. You will build your own Docker image to go in your own project. In order to do that, you need to start with something called the Dockerfile. After you have a Dockerfile, you can build that Dockerfile by saying docker build-t, which stands for tag, and you can give it an image name. And then you need to have a dot to specify the path, the build context path. It's very easy to forget the dot. Please don't forget the dot. Then you can run the command docker images to see all of your images, either that you've downloaded or built. It doesn't make a difference. They'll all be pulled down onto the Docker host, whichever Docker host you're using, and you'll be able to see all of them, whether you built them yourself or if you pulled them down. So the Dockerfile can be kind of hard to unpack and to kind of figure out the best way to write one. And in fact, this is where lots of optimization mistakes are made, and it's where you can, if you have a lot of knowledge about particular specific things with each of the commands, you can make a really high-performing image. For most of us, we don't really need to do that. I think that if you have to care about a very specific Dockerfile order, then you probably have bigger problems to work on other than just optimizing your Dockerfile. But it is good to do nonetheless. So I'm going to walk you through this Dockerfile, which is for a pretty simple Rails application, just to show you some of the common instructions that are in a Dockerfile, what they do, and maybe some tips about them. So the first is from. Each image needs to start with a from instruction. This is a Rails application that I'm building, so I'm going to use the official Rails image. The important thing about this from instruction, and what I really love about Docker, is that since everything is isolated, you can set your version in the Dockerfile, and then if you need to change it, then you just change the Dockerfile. Specifically for Ruby and Rails developers, this means no more gem set management, no more version management. All of the dependencies that are pulled down, like in a bundle install, are specific to the image and the container, so all of that logic goes in. Here in the Dockerfile, you don't need RVM or RB or whatever it is you want to use. So if I wanted to increase the version or use a different version, I would just go in my Dockerfile, change it, and use the different image that corresponds to that version. The second thing is maintainer. This is pretty straightforward. So if you want to have an address that people can email you weird questions about your Dockerfile when you're not expecting them, you can certainly put in your information there. The next is a run instruction. This is very, very common. You'll see this is probably the most popular instruction that you'll see in a Dockerfile, of course, outside of the from, which is required. So you can run any arbitrary command inside the context of a Docker image. So in this case, I want to make a directory that I'm going to later copy all of my stuff into, or to have that be kind of the working directory. So first I have to make it. So I'm just going to run a make-dir to make a place for my code to live. The second thing I'll do after that is to set that directory that I just created as my working directory. Keep in mind that Docker files, much like all of the code, most of the code that we write, is top to bottom. So if I were to have done this in the opposite direction and specified a working directory before I made the directory, my build would fail because Docker would say, I don't even know what you're talking about. Similarly, this next instruction, which is just copying my gem file into that directory that I made, had I done this in any other part, specifically before I specified the working directory, my build would fail. I have to tell Docker that I want everything to happen sort of in the context of my working directory before I can start executing commands against that directory. The reason I'm copying my gem file only and not the entire project is because I want to use this for development. I could certainly copy the whole entire project, but I'll show you the other way of getting code in, which is through a volume mount during the live demo that I'll do after we build this image. Okay, so we have gem file copied in, not the whole thing. It's because we're going to get the rest of the code inside of a running container in a different way. But I still want to bundle install because it's unlikely that my gem file is going to change drastically, and I'd rather just have that work done to begin with rather than kind of doing it every time at runtime. So again, I'm going to do a run command. This time I'll say bundle install. And remember, I can only say it because I've specified the working directory so that Docker knows to look in var app for my gem file and not in the root of the image. Okay? And then finally, the command instruction, cmd, says what we want to run our image with when it is run inside of a container. So in this case, we want to run it with Rails S. We also need to bind it to an address because we want to be able to see it in our browser. For my case, I'm on a Mac. I'm actually running Docker in a virtual machine that has Linux on it. In order to kind of make the jump, in order to see it in my browser, I need to make sure to bind it to an address. Otherwise, my port forwarding rules are just not going to work. So that's the basis of a Docker file. Once you have built your image, you can push it onto Docker Hub. You can also pull more images down from the Docker Hub to create your project. And once you have all of these services created, the way that you'll put them all together and stitch them together is using another tool that Docker has created called Docker-Compose. If you've been following Docker for any length of time, you've probably heard of the Fig project. So Docker bought Fig, and it kind of wrapped it up into Docker proper, and now it's called Docker-compose, which makes me grumpy because Fig was just much easier to type, and now you have to type out Docker-compose, so you can just alias it. I don't, because I give a lot of demos, and I find people get confused when I have it aliased to Fig, and they say, how are you using that? It's just an alias. I just really hate typing. That's my only complaint with these Docker tools, is that they're prefixed always with Docker hyphen, the tool name, and it's just a lot of typing. I hate typing, which is why I'm a developer. So moving on to Docker-compose. Docker-compose is an application templating tool. It just uses YAML. You can specify different, sorry, this is maybe a little bit hard to read. At the top level, specify the different services, and then within each of those services, you can specify any number of runtime variables. Don't worry about not reading this. I'm going to show you how to run one with the Rails application in just a little bit. And in fact, that little bit has come now. So this is going to be a little kind of live demo and a little bit more explanation about taking the knowledge that we have now about containers and about how Docker kind of manages the workflow around running containerized applications, putting it all together and actually running something with Docker and Docker-compose. The first thing that you need to do, and I imagine a lot of us also use Macs just like I do, you have to have some kind of Docker client installed on your machine. The old way of doing this was to use boot to Docker, and boot to Docker is now deprecated, and they've come out with something called the Docker Toolbox, which has basically everything you need to get up and running in a sort of Docker development environment. There's the client, machine, Docker engine, Docker-compose, which I will have to check. They just released that it's available now on Windows, but I'm not sure if that change has been absorbed into the Docker Toolbox quite yet. It also comes with something called Kitematic, which is if you would prefer to work with a GUI in order to kind of see how your containers are all talking to one another and set up applications. Kitematic is the tool to do that. It's another case of some students in Canada kind of made this product, and then Docker bought them and absorbed them into this Docker Toolbox, which is just meant as a bootstrapping thing to get you up and running with Docker if you're not already on Linux. If you have used boot to Docker and are transitioning to Docker Toolbox, there's an easy way to migrate your old virtual machines, your boot to Docker virtual machine, into Docker Toolbox. If you haven't done any of this and haven't used Docker at all before, it will look like I am using Docker directly on my Mac. Please don't be fooled. I'm just using Docker Toolbox. It seems and feels like I'm just running Docker natively on my Mac, but I'm not. There's a virtual machine that I'm talking to in the background, but it's kind of obscured from view to make it less interruptive into your normal development workflow. You can get Docker Toolbox at docker.com/toolbox. And once you have that, we can get started with running a Rails application. So there's a couple goals if we think about introducing containerization, a different virtualization style into our development workflow. As developers, there's stuff that we need when we're working. We need feedback from our code, and how can we do that if we're then kind of separating the runtime, putting it in a virtual machine and inside of a container? I want to see stuff happening, and I want to be able to directly impact and directly change the code that I'm running. So a couple things that we will still be able to do with Docker is viewing your application in a browser, editing your files in a local environment, and seeing the changes. We can run rake tasks like migrations or any other task that needs to be run against a service that's running in a container. You can still do that, even on a Mac or on a non-Linux environment. And of course, we also want to see log output. And we'll be able to still do all of those using Docker-compose running an application in containers. So, without further ado, this is the Dockerfile that we kind of talked through earlier. And I will show you. I'll sign into the App Store for some reason. Maybe I won't do that. Cool. Ever since I upgraded to El Capitan, I get these weird App Store prompts that are pretty annoying, actually. Okay, so we have a nice terminal window that's empty. In this directory is a very simple Rails application. This is just Rails new, nothing. No special database, it's just running SQLite. The difference is that I've added a couple files in order for us to be able to run it with Docker. The first thing is the Dockerfile. This Dockerfile is even kind of condensed from the one that I showed during the presentation because I don't want people to know my email, to email me about questions that they have. And I just kind of made it a little bit smaller. But that's all you need. Making a directory, setting it as a work directory, copying my gem file, running bundle install. So we'll build that by way of Docker Compose. So here is my definition of each service that goes into my Dockerized Rails application. And you'll notice that because this is just vanilla Rails running with SQLite, it's just one container, which is the Rails application. I've named it web, and I'm telling Docker to please build this web image from the Dockerfile in the current directory. So that's why it says build dot. That's simply instructing Docker to, by way of Docker Compose, for Docker Compose to run the build command and use the Dockerfile that I just showed you, so that before it fires up this container, it'll go through a build step. The next three things are kind of some development stuff that will help us be more productive. The first thing is I want to bind 3000 to 3000, so I want to see it in my browser. Of course, the process is running in a container, and I want it available to me outside of the container, so I have to make a port binding rule. The second thing is the volume mounting. So I said before that I only copied the gem file in because we were going to get the rest of the code inside the container with a different mechanism. And in development, this is exactly the way that you'll do it. What we're doing here is saying mount the current directory and put it inside of the container at var app, which, if you remember, is the same directory that I created where my gem file is. This way, I can edit stuff on my local machine and see the changes reflected in the container. And the third thing is the command to start the container. This is, you can override the command that we specified in the Dockerfile. You don't have to. In this case, it's just there to remind myself about what it is that I'm starting this container with. If I omitted this completely, it would still function. So those two things together, the Dockerfile and the Docker Compose YAML, allow me to say something like Docker Compose up. We will run it because log output is amazing. Just like this. I could give it the -d flag, similar to if you've used Docker before and you have run like docker run -d. It runs it in detached mode, which runs it in the background, and you don't see logs. We love seeing logs, so we will see logs right here. It's running on port 3000, and if you remember that I bound port 3000 to 3000, we can see it. But here's a problem, which is that, of course, even though it's just a vanilla Rails application, we need to do things like rake migrations and do other things against this service. This service is running in a container, which is on a Docker machine, virtual machine, which is like, a bajillion steps away from my actual terminal. And the way that you can access the process that's running inside this container is also via Docker Compose. So this is telling me to run this migration, which I will happily do. And actually, I'll do it in a different tab just for fun. I'm going to show you a very important thing right now, which is that if you are using Docker Toolbox, every time you open a new tab, this is really irritating. I probably should have written a script for it. But you need to export the environment variables in order to be able to say anything with Docker. So I was doing a Docker PSA to confirm that, in fact, this is set up correctly. I'm looking at the application that we just ran with Docker Compose. So we want to run that migration. And Docker Compose lets you run arbitrary commands, one-off commands against any service that it's running, just via Docker Compose run as well. This was called web. So I'm going to pass it the web name, which is the service that I want to run this command against. And I'm going to run the migration inside, sort of against this web container that's running inside of my Docker machine, virtual machine. So this is my host, my local host, my Docker machine, virtual machine, and then a container. So I'm running it against the Rails process in there. We can see that I had created the table named dogs, which is pretty great. And now we can go back and see no errors. I successfully ran the migration, and everything is happy. This is really straightforward because it's a vanilla Rails application. We're running a migration. In the context of the Rails application, it knows where my database is, et cetera. I didn't have to do any configuration. There were no environment variables being passed around between services. Everything was pretty straightforward. But what happens if you don't want to do that, and instead you want to run a multi-container application? This is probably what most of our lives look like, right? No one runs just like a plain, simple Rails application with absolutely no external dependencies. That's not really real life. I'm going to show you just very quickly an example of running Rails with an external database, in this case Postgres. And the biggest problem and the biggest frustrating point, even in my life, as I'm working on some pretty sophisticated stuff at CodeShip related to parallel test pipelines using ephemeral Docker containers. How can we get things in containers to communicate with one another? And the answer is pretty straightforward, but not that easy. So we can introduce something called a container link. We have access to environment variables. We can set environment variables to kind of be created and read by respective services. And of course, we'll have to monkey with our config just a little bit. The good news about this, though, is that Docker Compose makes this incredibly easy. So we'll look at a Docker Compose just sort of extended to include another application. So this is more or less the same Docker Compose file that we just ran, except including the external dependency of the database. The database is defined as another high-level service, so same level as web. It's called DB. And I'm getting it from the Docker Hub. I'm pulling down the image Postgres. So instead of build dot, I'm saying image Postgres. This tells Docker Compose that when it's time to run this service, please pull down the image from the Docker Hub, and specifically the image named Postgres. I could give it 9.4 or 9.3 or whatever I wanted, whatever kind of version I wanted. After this, if you don't specify a tag, it will just pull down the latest one. So I have that. But I need to show or somehow tell the web service that's running, so the Rails application, that it shouldn't really do anything until it knows that the database is available. To do that, and to do a couple other things, I'm going to specify a link. I'm going to say that this link is to the database. It has to be the same. DB and DB, those have to match. You have to know, it's sort of like, it only knows about the context that you give it. So if I were to say Postgres, even though the image is called Postgres, I named the service DB, so Docker would be like, I have no idea what you're talking about. Linking it will do a couple things. It's going to make an entry in your etc host file, so you can refer to the database just as host named database. It's going to create a couple, I think 6 or 7 environment variables for you to consume on the web, consume within the web service that will tell you where the database is actually located. And it will also run the dependency, so run the database before running the web. The biggest gotcha about this is that Docker really doesn't know what Postgres considers being available or what Rails needs for Postgres to be available. So if you use Postgres, you know that 9.4 has the new Postgres is ready thing. That's great. You probably will have to do some other, either use that check to make sure that Postgres is running and ready and able to be consumed, and have some kind of timeout retry so that if the web application, even if Docker thinks Postgres is ready but it's not really ready, that Docker will keep trying to fire up the web application, waiting for the dependency so that you don't get stuck in a state where Postgres is not ready, then your web application just kind of fails, and then you have to kind of do everything manually. So this sort of linking is what Docker considers. Docker is the one deciding about what ready means, not the actual service. So if you have other dependencies that need to be fulfilled within a service in order for it to be considered available within your application, you're going to have to do some external scripting or write something to make sure that that will happen. Other thing to note is just that the volume and the code is going to be passed in the exact same way as we did before, just by mounting the external volume. So mounting my code from my local host into the container. We're using Docker Toolbox, so remember we're doing another jump into the Docker Toolbox VM and then into the container. Same way though, you can edit it and have everything kind of ready for you in your development environment. And the other thing that we need to do is change the config database YAML file. As I said before, having the link will create an entry in your Etsy host file, so you're able to, all right, my star's a little misaligned. You're able to just refer to the database as host DB because of the Docker link. You could also do it a different way, which I will very, very quickly show you right now, which is to consume an environment variable. So we'll go to this, which is just a Postgres application. So same, just sort of vanilla Rails new, whatever, database PostgreSQL. And this, instead of using the host of DB in the config, first of all, just this is the same kind of database thing. We can see that I am going to instead pass in this line right here. So in the example I showed you before, that's sort of the easy, most simple, basic way, which is just to say host DB. You can also read the environment variable that's being set by the Docker link. They always have this format, which is DB, the name of the service, port, and the port that the service is available, so in this case 5432, TCP adder. That will be the host, the full host address of the database service. So again, either DB or you can read this environment variable. There's also environment variables for the port, for the full TCP address, a couple other things. Again, docs.docker.com has excellent documentation about all the things that container linking will do for you. So with that said, this is the same Dockerfile, more or less. We had to add a couple dependencies for Postgres to work, but basically just kind of installing the Postgres dependencies and then running the bundle install the same way as we did before. We should be able to say docker compose up, see our external database running, and let's see. My font size is super big, so I'm not sure if the web has started yet, but yeah, there we go. So this is 2 separate Docker containers running as part of the same application, stitched together with Docker Compose using environment variables. It's kind of a nice thing to have in your development environment. If you choose to develop this way, you can easily kind of give someone the Docker Compose file or include it in your repository so that your workflow is git clone repository Docker Compose up. And then people can have a development environment just up and running super, super easy. This is what we do at CodeShip with our mothership, with the kind of the basic Rails application that we use, is that we have a Docker Compose file in it, and any new engineer that comes in can just clone it and then say Docker Compose up, and then everything is just kind of there for you. A couple things just before we wrap up is that if you are doing things with Docker and you have containerized services as part of your application, and you want to use this continuous integration or continuous delivery tool, the workflow is kind of the same as if you were just distributing like the package of your application to whatever infrastructure that you're deploying onto. Of course, you would run tests. The only addition is that now you will build a Docker image and push it to some registry somewhere that then your machines can pull down and either reboot themselves or run new containers with the new image in it. Again, this is kind of a nice segue into always keep shipping. If you want to talk to me about continuous integration and continuous delivery with Docker, I'm happy to talk to you about it. It's what CodeShip does really well. thank you very much. And I think we have maybe a little bit of time for questions. I'm happy to answer any questions that you have either now or you can find me afterward. In the front, I saw your hand first, so.
Just a quick question. I saw someone talking about Docker recently, and they were saying what's quite interesting with Docker is, like, in the past when we had servers, you'd have like an operations person that would set up all the packages, make sure the security updates are installed. And now we're moving to a model of software where we're kind of like taking off-the-shelf things and just trusting them on face value. I guess my question is, how do you guard yourself as a developer to make sure that, like, the image is not compromised or it's all up to date?
Yeah, so the one thing that Docker, that's sort of hard with Docker is that if you pull something down from the hub, unless it's a official image, you don't really know what's on it, especially if you're just sort of testing things out. To solve this problem, Docker has something called Notary, which will sign the images. That way, when you pull it down, you'll get a notification that, yes, this image was signed by this organization and that you can trust it. They also have a couple other enable trusted content checks when you do pulls. That's turned on by default, and now you have to opt out of it in order to pull down an image that they've kind of deemed insecure. Of course, I think it's still worth it, even if you're using this Dockerized sort of development workflow and pulling things down from external places, that obviously you need to have someone doing security audits and security checks. Just because you're trusting someone else to write the code or pulling down, like, Redis, for example, that doesn't mean that your architecture and that your deployment implementation is secure at all, of course. So I hope that answers your question. Go ahead. Sorry, I can't see over my computer.
Yes. Hi. This works really good for a development environment, but for example, if you're using AWS, it kind of separates all those services for you. So what's the benefit of using Docker in production environment and deploying it on AWS, for example?
Yeah, I guess so. I don't work for Docker. If that solution doesn't work for you, then you're,
Just asking, what's the benefit of it? Is there any benefit that you see there, or you're just using it for development environment?
No, so we do, at CodeShip, we use it for development and we deploy using Docker. We have containers running on AWS and a couple other infrastructure services. So, of course, you could, there's any number of permutations of solutions that could work. We love using Docker because since we're running it in production, or since we do use it for development, we can further trust more that what we will get in production is exactly what we see in development. We could develop with Docker and deploy kind of with a different system, and then there's a mismatch between development, staging, and production. We like to keep it all together. Docker Machine makes it really easy, even if you're developing, to spin up a Docker Machine on DigitalOcean or AWS using their provider flag in Docker Machine. That way you can really, really have almost identical environments in production and development. That's why I like to use Docker, especially now with all of the new tools like Docker Swarm, machine provisioning stuff. It just sort of wraps everything and makes it super, super easy to use containers, both in development and production.
Hi, Laura. Okay. Thanks for the talk. I'm over here.
Oh, sorry.
Laura, no worries.
I was like, I can't see you. Okay.
I was wondering, I'm new to Docker, so this may be a very basic question, but as I understand, you run the containers on top of a host operating system, or they run within a host operating system, which seems to be Linux-based.
Yes.
What aspects of that host operating system will leak through into the containers? Does it matter which Linux distribution you're running? What do you have to look out for there?
Yes, so Docker, now I would say you can run containers without the privilege flag. There is something, so Docker has a thing called the privilege flag, which basically, again, you are sharing the host system. It's operating on a shared kernel. Containers operate via things like container or control groups, C groups, namespaces, networking namespaces, etc. So there really is, there was, it made it very easy to sort of exploit and have a container process break outside of the container. This has been a huge concern for Docker since day one. I could say now with confidence that if you're running a container and following and not, following their recommendations for how you should be implementing certain security things, that you can run it without worrying about things bleeding into other containers or containers kind of cross-contaminating other containers. When you run into a situation where you're either running Docker with the privilege flag, which explicitly lets it kind of break out, or if you are running Docker inside of a Docker container, which some people do. For example, you want to run Jenkins in a container. The process or the artifact of a Jenkins job is to create another container. So to do that, people say, I'm going to run Docker in Docker. I'll run Docker inside my Jenkins container so that Jenkins can run things. Then you have write-on-copy file systems mounted on top of other write-on-copy file systems. And there is some level that they can see what the other thing is doing. Don't do that. If you do have one Docker daemon and you're kind of following the rules, I guess, about how you should be running things, you have little to worry about, especially in combined with the trusted content things that Docker is doing now, like the Notary project. So a big question, also a really good question. So thanks. Okay, and if anyone else has additional questions, I'm happy to answer them afterward in the cafeteria or at lunch, so just find me. Thank you.